So we are in the middle of finishing 2.3. Does that sound right? We're going to be on worksheet 5B in a minute, but right now I was going to do this as a warm-up. You want this? You got this? Okay. I'll write, you talk. This is a nice short one. Do we need any placeholders? No. Okay. Okay, we got to make it exactly the first term match. So we need an x squared, and it doesn't matter to me where you write the x squared. I know some of you like write it back here. I don't care. Okay. So now we're distributing this. X times 3x is 3x squared, x times minus 2x. Then we have to be super careful because, yes, we're subtracting these both, okay? Okay. So now to get this to become this, multiply by 2, which will be, okay? I think 8. Okay, so two things. How could we rewrite our answer with a fraction? So we got 8. X plus 2 is our answer. Okay. What would we do to check our answer if we wanted to make sure this worked? Times x plus 2, good. Add the negative 8 on. So if I foiled this together real quick, I'd have 3x squared plus 6x minus 2x would be plus 4x minus 4 minus 8 would be 3x squared plus 4x minus 12, right? Okay. Any questions about any of that? Awesome. We are moving on. We did synthetic division yesterday. On the back, it talks about the remainder theorem. The remainder theorem simply says that if I want to know if this divides in evenly and is a factor, I have an option. I can divide it by long division. I can do it by synthetic division. But if all I really want to know is it going to come out evenly, I'm also allowed to find the 0 of this, which is 1, and substitute it directly in here. Because if it goes in evenly, okay, then it's going to be a factor. So the remainder theorem states that if a polynomial is divided by a factor, the remainder is the same thing you get by direct substitution. All right, so if I wanted to find f of 1 here, I'd go 1 squared plus 2 times 1 minus 7. So I'd have 1 plus 2 minus 7, which is negative 4. Did I do that right, guys? Okay, so that's predicting the remainder that I would get here. If I went through this real fast, I'd multiply by x, so I'd get x squared minus x. I'd subtract these. I'd have 3x minus 7. I'd multiply by 3. I'd get 3x minus 3, change my signs, and my remainder would be negative 4. So substituting in the 0 will give you the remainder. So substituting in the 1 gave me the remainder. So why is that good? Well, if I wanted to know if it was going to go in evenly, I could have just substituted it in from the beginning on my calculator and found out it wasn't going to work, right? It wasn't going to go in evenly. All right. The book suggests that that means if you had this crazy polynomial, it says the number of tickets sold during Northside's high school football season can be modeled by this crazy polynomial. where X is the number of games played. Use the remainder theorem to find the number of tickets sold during the 12th game. Okay, so if we wanted to know sold during the 12th game, we could type 12 cubed minus 12 times 12 squared plus 48 times 12 plus 74. Or we could do synthetic division with a 12 here. Gentlemen, put the coefficients down, bring down the 1 times 12, 0, 12 times 0 is 0, add 48, multiply this, and this remainder tells you there's 650 tickets sold. I personally would rather type on my calculator with the 12 because I can't do this necessarily in my head anyway, so if I need a calculator, I might as well just substitute it in. But it's just showing you that they both work. All right. And then we talked about this. If it goes in evenly, you will get a 0. So let's look at a couple of their examples because I won't do a good job of making one up. But it says, the factor theorem states that something is a factor if and only if when you plug it in, you get out a 0. So the remainder equals 0. So it wants to know, you have this, okay? Example, it says determine whether x minus 2 is a factor of this function. I can list 3 ways right now to do this. The first would be to graph it and see if there's a 0 at what value. X equals 2. Okay. The ways they want are to substitute a 2 into the polynomial. So I need f of 2, which would be 2, and then we're putting in a 2 for x. Was that a cubed, guys, before I scribbled on it? Plus 5 times 2 squared minus 14 times 2 minus 8. All right, that sounds fun. Can you all pull up your calculator and type that in quick? You guys are going to be 10 times faster than me. I'm terrible at this. Especially because I can't see the stupid thing. Ugh. All right, what'd you get? I give up. Did someone else get 56? No? Okay. What did you get? I'm just going to do it out here. Maybe I could use this one and it would work better for me because I could see it. Okay, so it's 2 times 2 to the third. Oh my goodness, why can't I really stink at this. Well, 0 would be great. That would mean it was going to go in evenly. Let's see. Plus 5 times 2 squared minus 14 times 2 minus 8. All right, a half hour later, Hofbauer gets it typed in, and I got 0. Okay. So we are predicting that it's going to go in evenly. Let's do it by synthetic, especially because we haven't reviewed that yet this morning. If I wanted to divide this into this by synthetic division, gentlemen, please be paying attention. What goes in the box if I'm dividing by x minus 2? The 0 is positive 2. This is in your notes. You should be writing this down. The coefficients across the top are 2, 5, negative 14, and negative 8. Okay. I bring down the first coefficient, the lead coefficient here. Then it's multiply, add straight down. 2 times 9 is 18. Add straight down. Multiply 2 times 4 is 8. Add straight down is 0. Now, I don't know which feels more comfortable to you. On that question, I actually felt better doing the synthetic division because I could do that in my head pretty quick, and this, it took me forever to type in a calculator. But if you feel better because you know this is just all typing in your calculator, they both gave you the remainder is 0. So is this or is it not a factor? It is a factor. What would happen if we divided it? Do we have the answer in front of us? We do. What is the answer if we were to actually divide that in there? This is a remainder. This is our constant x squared. Good job. 2x squared plus 9x plus 4. Okay, now we're down to a quadratic. Could we solve? Find the other two factors? Do we know how to factor this? Yeah. Yeah, and a 4 and a 1. I think you get 9 would be good. All right. This is... No, that's a great question. You can use synthetic when you have an x plus or minus some constant. Okay? And that's really what these questions are talking about anyway. All right? Your next question, part B, says, how could you have checked our answer on number 4 from the front? So here's number 4 that we did yesterday. What did we get for the remainder? We got a remainder of 10, right? So my question is, how could we have checked that that's right? Yeah, we were dividing by x minus 1. So the 0 was 1. So we could have done direct substitution of a 1 into this polynomial. So we would have had 1 to the 4th minus 3 times 1 squared plus 12, which would be 1 minus 3 plus 12. Negative 2 plus 12 would be 10. Did it give us the same thing? Predicted the remainder, yes. Negative 1, yes. Okay, great question. The question said if we were trying to divide this, we would find f of negative 1 to predict the remainder. Because it's the 0 that we're putting in here. Everybody, that helped some of you? That was a great question of clarification. All right. So this says use the factor theorem to determine if the binomials given are factors. So this particular one gives us an x minus 1 and an x plus 3, and it wants to know if these are factors. So the book comes up with this horrible polynomial. They say to figure out if x minus 1 is a factor, they put in a 1, did synthetic division. Did it work? How do we know if it's going to be a factor? It goes in evenly, so the remainder is 0. That one does not. X plus 3, they put a negative 3 in here, and it came out 0. So that one is a factor. And if they were to write out the factored form, this meant x plus 3. And this, did I use that term yesterday? This is called the depressed polynomial. Okay. This little guy down here, 4x cubed plus 9x squared minus 2x plus 1, is the depressed polynomial. Now, I don't know how to factor that any further yet, unless I could find another factor. That's where we're going with this. Okay. So we're supposed to determine if this is a factor. Since it's a nice x plus or minus a constant, we can use synthetic division. We're going to put across, in the box goes what? Negative 5, and across the top goes, do we need any placeholders? We had an x to the third, x squared, x once, and a constant, so we don't need any placeholders. Okay, someone else describe this. Okay. Add, good. Okay. So the remainder 0 shows that it is a factor. Right now we have a factored form that would have what? Anybody tell me what we have so far? We divided in x plus 5, and what's left? Everybody good with where we got that? Okay. Can we finish factoring? Does it factor further? Is it x minus 6, x minus 1? That would give us a negative 7 in the middle, right? And a positive 6. Okay. So by finding one of the factors, we were able to completely factor this. And actually, we could now find all of the zeros, right? The zeros are at negative 5, 6, and 1. All right, but what they wanted up here was this answer. In any order, doesn't matter. All right. I have an extra example here. And this is what you're going to have to do on the quiz. And we're going to practice this some more in a minute. But what happens is I'm going to give you this big messy polynomial. You're going to graph it actually and see a couple places that it crosses nicely. Austin, are you taking these notes? Okay. If you see on the graph that it crosses nicely at negative 4 and 5, you're going to try one of those, do synthetic division. You don't have this one, so just watch real quick because I want to show you what we're going to do. We're going to do what's called successive divisions. Bring this down, multiply. Somebody check that I don't do something stupid. Multiply. I think I did that right. Okay. If it's a factor, it has to come out 0. Everybody's clear on that? If you graphed it and it crossed exactly at negative 4, it has to come out 0. Now, to find if 5 works, because 4 worked, you can actually divide the 5 in now. This is called successive divisions. Up here it says, use the depressed polynomial for the second one. You have to do successive divisions. Okay, so now if I bring down this 2, I get 10, add, I get 1, multiply, I get 5, remainder is 0. Okay, what you just showed me is that x plus 4 was a factor, x minus 5 was a factor, and what's left? Okay? We are going to do this, and they want us to do successive divisions. Can somebody graph this real fast first? Because it says we should graph it first because we want to know which ones are going to work. If they're not all going to work, we don't want to do them because we're just wasting our time. Will someone read it to me off your worksheet? 3x to the 4th, is that right? Plus 8x to the 3rd. Yeah, now I can see. Thank you, though. Minus 32x plus 12. All right, I'm going to start with a standard window. Well, that's interesting. Are my axes turned off? Second format, they are. All right, so it suggests I should try what here? A 0 at 1, -2, or +2? So if I have this graph, I can do trace 1. Is it a 0? I got 1 is not a 0. Did you guys get 1 is not a 0? I got negative 24 work, okay? Then negative 2 is a 0 and positive 2 is a 0. Did anybody else get that? Okay, so the first one didn't work. Put this on here. Okay. So this one is going to be no. I could plug a 1 in to prove that it didn't work, or I could do the synthetic division, which doesn't sound very fun. But we did it on the graph and it didn't work. So now let's do negative 2. It was x plus 2 is the factor, but negative 2 is the 0. The coefficients are 3, 8, negative 15, negative 32, and 12. Okay. Try it out, see how you do. Yikes, I don't know, I'm getting really big numbers. Actually, I got it to come out 0. It's really easy to make a mistake along the way here, so let me know if you're confused where I got a number. Anybody not getting 0? All right. Remember, successive division. That means you don't go back to the original polynomial. You now try the next factor in this one. What are we going to do next? Yes, this one worked. And now we're going to put in the other next 0, which is positive 2, into this polynomial. Bring down the 3. 2 times 3 is 6. So this worked. All right, so here's what we did. We have a factor of x plus 2. We have a factor of x minus 2. What's left is what? Okay, do you think we could maybe factor that further? I'm thinking that 3x times 3, like that, would be 9. And if that was a positive, and this was a negative 1, we'd get 8, and a negative 3 at the back. Okay. Could we double check that that worked? What are the 2 zeros you would check on your graph? Now, we already checked negative 2 and positive 2. Negative 3, right? And 1/3. So if I went back here and I did trace 1 divided by 3, that's how you check 1/3, it should say exactly 0. And then negative 3 was the other one, and it says 0. So we found all 4 zeros accurately, and we found factored form, completely factored form. All right, so this is just an overview. It says if R is the remainder when you do synthetic division, then R is what you would get by direct substitution if you put it in. If the remainder is 0, it is a factor and an x-intercept and a solution. It's just covering all that vocabulary. All right. This is a homework question out of the book that it says I will do with you on the assignment. This is a horrible, nasty question. I need everybody to type this in and find me a couple zeros. Sorry. Try to make it so I could do it. Well, not there. Here, Hofbauer. Yes. Anybody else having trouble graphing? I can guess right now the issue is you have a plot on. Oh, it should be. You can't graph if your plots are turned on up here very well. Turn plot 1 off, go up and hit enter. It's darkened in. Okay, anybody finding some of the zeros? Look at the graph, find some of the zeros for me, guys. What did I just do? I don't know why this is such a struggle for me. Oh my goodness, that was supposed to be a 3 and I just made it a 2. Did you find zeros? Not one person found a single zero. All I really want to know is where's it crossing X? So can you estimate some? -6, +2, either one of those working? I'm just guessing from looking at this without fixing the window. If I do trace, did you say -6 worked or not? -6, enter, that's a 0. Actually 2 doesn't look like it works, right? Oh, it's 2.5, okay. Let's start with 6. Found one at 6. So now we got to do synthetic division painfully. All right. So I need somebody with a calculator. 6 times 6 is 36. 13 plus 36 is 6 times 49. Minus 153. 141 times 6. Oh my goodness. What is it? Plus 54 is 900. Times 6 is plus 724 is something's wrong. Because it's got to come out 0. Oh, it wasn't 6, dingbat, Hofbauer. What was the 0? It's not 6. It's -6. That makes all the difference in the world. Okay. -36 plus 13 would be -23 times -6. Thank you. Minus 153 times 6 is 90. Positive 90. Added together is 144 times -6 is plus 724 is times -6 is positive 840, I hope. All right. Well, that's lovely. I don't know how to graph that any further. Right? That I picked this question to do on a video and I'm not. We could try some of these other numbers, but what if I just do a zoom out? Is there another nice 0 we can see anywhere? Not so much. All right. What was this? This one was positive 2.5. All right, I'm going to do 2.5 here. Someone's with your calculator. What? For 2.5, it's not exactly negative 2.5? Okay. So 6 times negative 2.5, somebody? 12. Added to negative 23 would be negative 38 times negative 2.5. Positive. Okay. Would be 80 times negative 2.5. Would be 56 times negative 2.5. Something's wrong. What did it, oh, this was negative, so this is positive. Okay. Woo, because it had to come out. Does anybody find this 0? I don't know why I picked this question. It's horrible. It's 2 1/3, which would be 7/3. I don't think we want to do synthetic division with a 7/3 very bad. Okay, 6 times 7 divided by 3 would be 14. This would be negative 24 times 7 divided by 3 is negative 56. I hope someone's checking me. Which is 24, which is positive 56. All right. Okay, well, we actually now can factor it completely. What are the factors, guys? What? Oh, what's left here, yes, is a 6x squared minus 24x plus 24. What can I take out of all those? A 6, which would be x squared minus 4x plus 4. Okay. So I have a 6, and here this would factor x minus 2 and x minus 2. Which means positive 2 is a 0. Guys, put in 2. 2 worked? Why doesn't it look like it's going through 2? I don't know, maybe we should have fixed our window. I'm doing a horrible job of explaining this. All right, what are these 3 remaining ones that have to be factors? X plus 6, x plus 2.5, and x minus 7/3, which means we could have written this differently because we could have distributed that 6 back here. All right, so you have to be able to find complete factors. I do hereby solemnly swear I will not ask one that starts with a degree 5, okay? Because that was just horrible. Okay, I'm pretty sure there's not even one in the homework that's that bad. The other thing is, it says find the value of k so that the remainder is 0. Anybody have any idea how we could do this? You have to do these, and I said I would do 53 together with you. We want this to come out 0. You can do this by synthetic division, and a lot of teachers would teach it by synthetic division. But what is the other choice? Do you remember what we can do instead of synthetic division? Direct substitution, exactly. What would I want to substitute in here? I would want to put in f of 2, and it needs to come out 0. So I'm going to put a 2 in up here, and it will be 2 to the 3rd minus k times 2 squared plus 2 times 2 minus 4, and it's supposed to come out 0. Now, is that something we should be able to solve because it only has one variable? This is 8 minus 4k plus 4 minus 4 equals 0. Well, we can just do that. If I actually added the 4k to the other side, but we get k equals 2. You can do it by synthetic substitution, and you have to work with a K in your little information, and it's a pain in the neck. Okay, I don't actually think that's on the quiz. The 4 or 5 questions that you still need to do on this, guys, are on page 115 here. Remember, it said I would do 53 and 59 together, and you wanted to kill me over 59. I wanted to kill me. Okay, these are the 5 questions you still need to do on section 2.3. Anybody need to write that down? You have it on your homework check. You also have it on the blue sheet. But it's page 115, 31, 41, 55, 57, and 58. Read directions carefully, guys. You have to start by graphing on a bunch of those to find zeros, okay? You're not just guessing random numbers. All right. I'm going to start 2.4. We're not going to get very far, but that's okay because I just want to start with the basic idea. The first idea that comes up in 2.4 is that you don't have to graph it, needless to say, because Hofbauer didn't have a graphing calculator when she was in this class, okay? There's a way to predict which numbers you should try without having to graph it. This is called the rational roots theorem, rational zeros theorem, okay? It says the rational zeros, rational, what does rational mean? All the nice zeros that are either whole numbers, positive or negative, which means integers, or fraction. Okay, they can be repeating fractions or terminating fractions, or terminating decimals like 2.5. Okay, all of those nice factors come from a list that can be derived by finding all of the factors of the constant term divided by the factors of the leading coefficient. Does it look like this on your sheet, maybe? It says this, right? It says P over Q. So this is what the question will say on the quiz. A list of all possible rational zeros. Okay? And you are going to have to take all of the factors of the constant term and divide it by the factors of the leading coefficient. We'll do enough of these that everybody will get it. The problem is some of you will do them upside down. The factors of the constant go on top. The factors of the leading coefficient go on the bottom. Everybody find it on their notes? All right, so here's our example. It says x cubed minus 5x squared minus 17x minus 6. Determine if there are, what the list of possible zeros is. Well, the constant is -6. The leading coefficient is what? Leading coefficient is 1. So all we have to do is the factors of 6, plus or minus 1, 2, 3, or 6, over 1, the leading coefficient. And this gives us a list of all the possible rational zeros. You guys have a graphing calculator, so you can actually do it. They found -2 worked. This depressed polynomial was this. Does this factor further? Guess what? It does not factor further. X squared minus 7x minus 3 does not factor further. You're going to have to find all the zeros in section 2.4, which means you're going to have to find imaginary zeros as well. Okay? So to find imaginary zeros, you get to use what? Quadratic formula. Okay? I'm going kind of quick here. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we have 7 plus or minus the square root of 61, I think. Someone check me. I just wanted you to type this in here, guys. Yes? 61, because this is 49. This is minus, and a negative back here would make it plus 12. All right. So the zeros were where? Where are the 3 zeros? Does anyone understand where we just found the 3 zeros? Okay. One of them was at -2. One is at 7 plus the square root of 61 over 2, and one is at 7 minus the square root of 61 over 2. There's the 3 zeros. Those are all 3 real. There's no imaginary I anywhere. But these are going to be crazy, horrible decimals when you try to find them on your calculator. Yes. No, I don't care. All right. All I want to do. Are we done it? Well, okay. We got 2 minutes, so we can do this. All I want to do is list all the possible rational zeros. Do you have these? No? Okay. That's all I want to do because I want to just talk about where you get these. So if you want to write one of them down, you can, but it's all the factors of the constant. Okay, guys, help me out. What are all the numbers that divide into 36? Start with 1. Okay, we can list them that way if you want. 2 and... Okay, and on the bottom go all the factors of the leading coefficient. What are the only factors of 2? Okay. You do not get credit if you write that on the quiz. You have to write out what that means, okay? All of those top numbers put over 1 would be this. What happens, though, if I put all those top numbers over 2? 1 over 2 would be 1/2. 2 over 2 is 1. It's already on my list. 3 over 2. 4 over 2 is 2. It's already on my list. 6 over 2 is 3. Already on my list. 9 over 2. 12 over 2 is 6. Already on my list. 18 over 2 is 9. 36 over 2 is 18. Plus or minus, that's the list of possible rational zeros. Okay, help me with this one. What are the factors of 21? Much shorter list. 1, 3, 7, and 21. What are the factors of the denominator? Okay, so if I put those over each other, all of those over 1 would just be, but what if I put them all over 3? I get 1 over 3, 3 over 3 is 1, already on my list. 7 over 3, 21 over 3 is 7, already on my list. Okay, there's a question on the quiz. Just write out all the possible rational zeros. Now tomorrow we'll talk about what you have to do with those. Okay? So we didn't get as far as I wanted today, but you need to finish up 2.3.